You get home at the end of the day. You stop at the entrance, reach into your pocket for the key, and lean toward the lock almost without noticing. The key turns. The handle moves down. Your hand pushes the wooden door, and it swings inward. You cross the threshold, step inside, and close the door behind you. The movement is so automatic that it rarely deserves a second thought. But stop for a moment. Why do you push to enter your own home? Now, replace the house with a movie theater, a school, a shopping mall, or an airport. In many of these places, doors along exit routes move in the opposite direction. When a crowd needs to leave the building, people push the doors outward. The difference seems minor. It is simply the direction a panel swings on its hinges. But that choice can determine whether someone enters comfortably, rain gets inside, a pedestrian is struck on the sidewalk, or hundreds of people can escape a fire. The explanation almost everyone repeats is incomplete. The first answer seems obvious. Residential doors open inward for security. When the door swings inward, traditional hinges face the inside of the home. Their pins and other components are less accessible to someone outside. On older models, this makes it harder to remove the door by attacking the hinges directly. It also allows the resident to open the door just a crack, remain protected behind it, and see who is outside. If they decide not to let the visitor in, they can step back and close the door. All of that makes sense, but an outward opening door can also be secure. Modern hinges have protected pins, concealed fasteners, and systems that prevent the door from being removed. Multi-point locks secure it at several points along the frame. In some cases, pressure from outside pushes the door even more firmly against its frame. So, security explains part of the choice. It doesn't explain everything. Then comes the second theory. It's because of snow. If the door opens inward, a layer of snow outside doesn't immediately block its movement. The resident can open it, assess the situation, and begin clearing the accumulation. That advantage is real in certain buildings and climates. An outward opening door can become trapped by packed snow, ice, or objects left in front of the entrance. But this explanation runs into an enormous problem. Millions of doors open inward in cities where it never snows. Tropical homes, apartments in warm regions, and coastal residences all repeat the same configuration. At the same time, some cold countries have many residential doors that open outward. Snow affects specific designs. It doesn't create a worldwide rule. The third explanation seems more comprehensive. It's tradition. Carpenters learn from other carpenters. Builders repeat familiar details. Manufacturers produce doors, frames, and hardware according to the standards that sell best in each region. Residents become accustomed to a particular movement. But tradition doesn't appear out of nowhere. If a solution is repeated for centuries, there are usually practical, economic, or cultural reasons behind it. Even when the original reason disappears, the custom can remain. Calling something a tradition merely replaces the question, why did that tradition begin? The fourth answer is the weakest of all. Doors open inward because they always have. They haven't. Some ancient doors swing inward. Others swing outward. There are double-leaf gates, sliding panels, entrances protected by curtains, and openings sealed with removable pieces. The history of the door doesn't follow a single path. To find the missing piece, we need to return to the moment when an entrance stops being just a hole in a wall. The earliest doors don't face a single problem. They have to solve several at once. A home must allow its occupants inside while making it harder for intruders to enter. It must keep domestic animals in and other animals out. It needs to control wind, rain, cold, smoke, and light. A large opening makes passage easier but increases exposure. A small opening offers better protection but makes movement uncomfortable. A heavy door resists impact but requires stronger hinges and supports. In a simple structure, the walls may be made of wood, stone, earth, or sun-dried brick. The door must fit irregular materials. The frame, the fixed structure surrounding the opening, must support the door's weight and receive the lock. Hinges evolve as well. Wooden components, leather straps, pivot joints, and metal hardware allow different kinds of movement. As blacksmiths produce stronger components, doors become larger, heavier, and more precise. The direction of their swing begins to affect the entire building. If a door swings inward, it needs a clear area inside the room. If it swings outward, it needs open space in front of the facade. That changes the placement of furniture, steps, hallways, sidewalks, and overhangs. Imagine an old house facing directly onto a narrow street. A door that opens outward intrudes into the public right-of-way. It can strike a pedestrian, block a loaded animal, or collide with a passing cart. When several houses line the street, every outward projecting door becomes an obstacle. Opening inward keeps the movement within the property. For detached homes, the problem changes. There is more room in front of the house, but the entrance still has to deal with visitors, wind, and rain. An overhang can shelter the door. A small vestibule, the transitional space between outside and inside, can control the flow of cold air. Architecture begins to shape the gesture. A person arrives, unlocks the door, pushes it, and moves forward with it. The motion guides the visitor inside. Once across the threshold, they can close the entrance without stepping back into the rain. This is the first convincing answer. Residential doors open inward because their everyday use is organized primarily around receiving a small number of people. The resident controls the entrance. The visitor waits outside. The door doesn't occupy the sidewalk. Its hinges can remain protected, and it can be closed quickly after someone enters. In a shared apartment hallway, the advantage becomes even clearer. If every apartment had an outward opening door, one door could block the hallway, strike a neighbor, or interfere with the apartment directly across from it. On narrow stair landings, the risk of conflict would be even greater. By opening inward, each home contains its own swing path. The swing path is the area swept by the door as it rotates. Even a door less than 3 feet wide occupies a substantial amount of floor space as it completes that movement. Nothing can remain within that area. There can't be a tall cabinet blocking the door. A thick rug may catch its lower edge. A light switch placed behind it becomes difficult to reach. Poorly positioned furniture prevents it from opening fully. Every door creates an invisible zone where the room must remain clear. In a home, sacrificing part of the entry hall may be acceptable. In return, the sidewalk, porch, or exterior hallway remains unobstructed. But the solution comes at a cost. A small room loses usable space. A wheelchair user may need to enter, position the chair, and maneuver around the door. Someone carrying groceries has to push it while moving forward without letting the bags strike the frame. Neither direction eliminates every conflict. The choice merely determines where those conflicts will occur. The frame reveals another difference. When a residential door opens inward, its exterior face can close against stops and seals built into the frame. With certain orientations, wind pressure pushes the door against these components, helping limit the passage of water and air. But that depends on the entrance's exposure. If the prevailing wind pushes in the opposite direction, it may try to pull the door away from the frame or force it open. In regions exposed to severe storms, outward opening doors can offer advantages because certain pressures compress them against the structure instead of pushing them inward. Weather resistance doesn't depend on swing direction alone. Thresholds, gaskets, drip edges, eaves, elevation changes, and installation quality determine whether water gets inside. A poorly installed door will still leak, regardless of whether it opens inward or outward. Architecture never provides an isolated answer. Even hinge placement requires a compromise. When a door opens inward, conventional hardware remains protected on the interior. But depending on the frame and lock, the door may be more vulnerable to certain kinds of forced entry by impact. When it opens outward, a frontal blow may push it against the frame, but the exterior hinges must be protected against removal. Modern solutions use additional details. Security studs, tamper-resistant screws, and specialized hinges prevent the door from being removed even when the hardware is accessible. So, there is no inherently safe side. There is only a secure or insecure assembly. Climate adds more suspects to the investigation. In areas with heavy snowfall, opening inward prevents accumulation outside from blocking a primary exit. In other buildings, an overhang or vestibule solves that problem and allows doors to open outward. In regions with strong winds, the direction must account for prevailing gusts. An exterior door can be torn from someone's hand and thrown open violently. Wind can also make it difficult to close or damage its hinges and door checks. In hot climates, the priority may be ventilation, shade, and a connection to outdoor spaces. Double doors, sliding doors, and broad movable panels can replace the inward or outward choice entirely. That is why different countries arrive at different answers. In parts of Scandinavia, outward opening residential exterior doors are common. The custom may relate to preserving interior space, local construction practices, weather sealing, and regional requirements. Elsewhere, especially where homes sit close to sidewalks or shared hallways, inward opening doors remain dominant. Apartments may follow different rules from detached houses. A door opening outward onto a private balcony doesn't create the same risk as one projecting into a shared hallway. The word home conceals dozens of different situations. But one contradiction remains unanswered. If opening inward is so convenient, protected, and well-suited to a residential entrance, why do so many emergency doors do exactly the opposite? The answer appears when we replace one person with a crowd. Imagine a packed room. An alarm sounds. The lights fail. Smoke begins to spread. Some people can see the exit. Others simply follow the movement of those ahead. The crowd surges toward the door. If it opens inward, someone has to make room to pull it against the flow. That requires the people in front to step backward, while everyone behind them continues pushing forward. Under normal conditions, that movement is simple. In a panic, it can become impossible. The person closest to the door tries to pull it open but can't, because other bodies occupy its swing path. The people behind can't see the problem. The pressure increases. The door remains shut, not because it is locked, but because the crowd itself prevents it from moving. Now reverse the direction. The door opens in the direction of escape. Pressure against the door helps push it outward. No one has to step back to clear an interior swing path. This is where the investigation changes completely. A home and a public building aren't trying to solve the same problem. A residential entrance receives a family member, a visitor, or a small group. Movement is controlled. There is time to unlock, open, and close the door. A theater, school, arena, or assembly hall must allow many people to leave at once, including under conditions of smoke, noise, fear, and poor visibility. A home is organized to control entry. A public building is required to protect egress. That distinction wasn't born from theory alone. It was written through tragedy. In the late 19th and early 20th centuries, fires and crowd crushes in theaters, factories, assembly halls, and other gathering places exposed fatal combinations. Too few exits, locked doors, poorly marked escape routes, narrow stairways, combustible materials, and openings that were difficult to operate. In the Triangle Shirtwaist Factory fire in New York in 1911, 146 workers died. The disaster involved multiple failures, including dangerous working conditions and problems with escape routes. Its impact intensified demands for inspections, fire protection, and stricter regulations. It would be wrong to say that a single door caused all those deaths. Disasters occur as systems of failure. One exit may be locked. Another may be too narrow. Smoke reduces visibility. The crowd converges on the same point. A stairway can't handle the flow. A door requires a movement incompatible with the pressure of the people around it. Modern engineering learns to analyze the entire path. Leaving a seat, reaching a hallway, finding a stairway, passing through a door, and arriving at a safe location are all part of an escape route. If a single point interrupts movement, the entire system loses capacity. It is within this context that doors swinging in the direction of evacuation and panic bars become widespread. A panic bar is a horizontal device installed on the interior face of a door. Instead of searching for a small handle, turning a key, or deciphering a complex mechanism, a person presses the bar with a hand or the weight of their body. A single movement releases the door. That matters because, during an emergency, seemingly simple abilities can disappear. Smoke irritates the eyes. Heat changes behavior. A person may be carrying a child, supporting someone who is injured, or simply trying to stay on their feet. The device must work without requiring precision. But not every door in a store, school, or hospital is universally required to open outward. Rules vary by country, occupancy, number of people, environmental risk, and the function of that particular opening. Building codes often require certain doors along escape routes to open in the direction of egress when they serve higher occupancy spaces or areas with specific hazards. Other interior doors may swing in the opposite direction when they serve small rooms. Even within a hospital, different doors serve different goals. A patient room door must support patient care and the movement of equipment. A fire door must limit the spread of smoke and flames. A final exit must allow safe evacuation. The type of building alone doesn't determine the direction. The door's function does. That distinction also corrects a common misconception. Store doors don't always open exclusively outward. Some have two leaves that swing in different directions. Others are automatic and slide sideways. Some buildings have revolving doors accompanied by conventional exits. Small businesses may have inward opening entrances when local codes allow them. What matters is that the required evacuation routes provide the capacity, operation, and direction appropriate to the number of occupants and the level of risk. The decisive word isn't public, it's egress. Egress is the path used to leave a building and reach a safe location. Today, an architect doesn't choose a door's swing direction simply by looking at a floor plan and deciding which side looks better. First comes circulation. Where are people coming from? Where are they going? How many will pass through that opening? Is there a narrow hallway? Could the door block another opening? Could it reduce the usable width of an escape route? Then comes accessibility. Is there enough room for a wheelchair user to approach, reach the handle, open the door, and pass through? Does the hardware require excessive force? Is there clear floor space beside the door for maneuvering? A door can be wide enough and still be difficult to use if someone becomes trapped between the door and a wall. The exterior space matters too. An outward opening door can project onto the sidewalk, strike someone, or occupy part of a stairway. If there is a broad private landing, that problem becomes less serious. If the building ends directly at the property line, it becomes critical. Wind enters the decision. So does rain. The same is true of snow, security, furniture, equipment, seals, and local customs. In a small home, opening outward may free space for a cabinet or improve circulation through the entry hall, but it requires an exterior area that remains permanently unobstructed. Opening inward protects the exterior path but occupies valuable space inside. One solution resolves a problem and creates another. Sliding doors eliminate the swing path but require space alongside the opening or a pocket inside the wall. They may provide different levels of weather sealing and require well-maintained tracks. Pivot doors create broad, visually striking entrances, but their pivot axis occupies part of the clear opening. Double doors increase passage capacity, though they require additional hardware and coordination between the leaves. Even the side where the handle is placed changes the route. A poorly oriented door may force someone to walk around the entire panel every time they enter. It may hide a light switch, obstruct the view of a stairway, or open directly into a piece of furniture. That is why the correct direction doesn't exist outside its context. There is only the appropriate direction for that door, in that building, under those codes, and within that environment. And there are still situations where fire safety appears to conflict with security. A home needs to keep intruders out. An emergency exit must allow any occupant to leave quickly. If the exterior lock is too strong and the interior mechanism requires a key, protection against entry can become a trap during an escape. The solution is to separate the two movements. From outside, access can remain controlled. From inside, the door must release in a way that matches its function and the applicable regulations. In a high-occupancy building, that may mean a panic bar. In a home, it means ensuring that residents can open the exit without searching for tools or completing a complicated sequence. The door becomes a negotiation between allowing and preventing. Allowing passage for those who should enter. Preventing entry by those who should not. Containing wind, rain, smoke, and fire. And opening quickly when remaining inside is no longer safe. Now we return to the opening scene. You get home. Take out your key. Turn the handle. Push the door. The gesture remains simple, but it no longer seems arbitrary. The door moves inward because someone decided where its swing path would occupy space. The frame contains seals because the entrance must control wind and rain. The hinges are positioned according to security and maintenance requirements. The door avoids projecting onto a sidewalk, porch, or shared hallway. In another home, in another country, it may open outward. The climate may be different. The landing may be private. Local construction traditions and codes may favor another solution. And in a crowded theater, the same movement takes on a different meaning. There, the priority isn't to welcome one person calmly. It is to allow hundreds of people to leave without having to step backward against the crowd. A door's swing direction seems like an insignificant detail. In reality, it represents centuries of carpentry, architecture, safety, human behavior, and engineering. Every hinge reveals a choice. Every frame defines a boundary. Every handle determines how someone passes through a wall. A door never opens in only one direction. It reveals how that building was designed to protect, welcome, and, when necessary, save lives. And if such an ordinary movement conceals a story this complex, follow the channel to discover how many other invisible decisions are hidden inside the homes and cities we use every day.